There's a real elegance to improvement. Not the big, dramatic, tear-it-all-down kind of change, but the small, almost invisible edit that just makes everything better. Today, we're going to look at one of the most subtle but powerful forms of this idea, and it's happening millions of times a second inside our computers. So let's start with a question. Imagine you have to edit a 1,000-page book. How would you even start? The obvious answer, right, is you read the whole thing, from page 1 to the end, looking for ways to improve the story, the characters, the flow. It's a massive top-down job. But what if there was another way? Yeah, what if you just ignored the big picture for a second, and instead, you slid a tiny little window across the text, only looking at 1 or 2 sentences at a time? You wouldn't be fixing major plot holes, sure, but you could definitely spot a clumsy phrase, or a repeated word, or just a simpler way to say something. You could make thousands of these tiny local improvements. And it turns out, this idea of a small sliding window, that's precisely how computers do a kind of secret last-minute proofreading on all the software we use. It's this hidden editing process that makes our digital world faster and smoother and more efficient, all one tiny step at a time. All right, so this whole process actually has a name. It's one of the foundational techniques in getting programs ready to run on our machines. You can really think of it as a microeditor, but for computer code. It's called Peephole Optimization. The compiler, which is basically the program that translates human-written code into machine instructions, takes one last look through this tiny peehole right at the very end of its process. It just slides this little window across the instructions, and if it sees a sequence that could be shorter or faster, it just swaps it out for a better one. It's such a simple idea, but its impact is, well, it's huge. And what you're looking at here, this is what those sentences actually look like to the computer. This isn't pretty Python or C++ code. This is low-level assembly language. To us, it looks dense, maybe a little cryptic, but to the Peephole optimizer, it's just a text full of opportunities for small, clever little edits. So how does this micro-editor actually work? Well, it has a few favorite tricks up its sleeve. Let's call them 4 simple but incredibly effective edits it's always looking for. These are its basic rules for making code just a little bit better. The first edit is the most intuitive one. Just like in writing, you want to avoid saying the same thing twice. The optimizer looks for instructions that are totally unnecessary because their job has already been done. And this slide shows it perfectly. The before code tells the computer to store a value from a register. Think of that as a tiny slice of super fast memory into a regular memory spot. Then, the very next instruction tells it to load that exact same value right back into the exact same register. It's like writing something down on a piece of paper just to immediately pick it up and read it back to yourself. The optimizer sees this, realizes that second step is completely pointless, and just deletes it. A tiny edit, but it saves a little bit of precious time. Okay, the second trick is all about finding shortcuts. If the code is giving you directions to get from point A to point B, the optimizer double-checks to see if there's a more direct route. This is such a classic example. The code says jump to location L1, but then when the program gets to L1, all it finds is another instruction that says, okay, now jump to location L2. The optimizer just simplifies this by changing the first instruction to go to L2 directly. It's like being told to go to room 1, but when you get there, there's just a note on the door that says go to room 2. Next time, you just go straight to room 2, right? That's exactly what the computer learns to do. This third edit is basically doing the easy math problems ahead of time. See, some operations in code are mathematically, well, useless, but they might pop up as a side effect of how the code was generated. The optimizer is smart enough to just solve them on the spot. I mean, it's such a simple concept, but it's so powerful. Some instructions literally do nothing. Adding 0 to a number doesn't change it. Multiplying by 1 doesn't change it either. The optimizer recognizes these basic rules from algebra and just removes the entire instruction. The program doesn't have to waste a single cycle doing math that has no effect. And our final edit, think of this one like learning the local dialect. Sometimes a specific computer processor has special, highly optimized instructions for really common tasks. It's like a kind of local slang that's way faster than the standard way of saying something. Adding 1 to a number is an incredibly common thing to do in code. The standard way to do it might take a couple of steps, but a lot of processors have a special single auto increment instruction that does the exact same thing, only much, much faster. The Peephole optimizer knows the local slang of the machine it's writing code for, so it swaps out the standard phrase for the faster, more efficient local idiom. So, Those are the edits. And they seem so small, right? Almost trivial. Removing one instruction here, changing a jump there. But when these tiny edits are applied millions and millions of times across all the software we run, the collective impact is just enormous. So why does any of this matter to you? Because every single one of these tiny optimizations helps make your apps launch faster and your games run smoother. By making the code do less work, it uses less energy, and that means longer battery life on your phone and your laptop. This isn't some abstract computer science idea. It's a fundamental reason why our digital world feels as fluid and responsive as it does. And really, that's the main takeaway. Underneath the surface of every app, every website, every game you use, there is this quiet, relentless process of improvement going on. A little micro-editor looking through a tiny peephole, making countless invisible edits that all work together to create a seamless experience for us. And it leaves us with a rather beautiful idea to close on, one that connects this very technical process back to a more universal kind of principle. It's a great reminder that you don't always need some grand, sweeping redesign to make things better. Sometimes the most profound and elegant results come from just looking through a small window and fixing what you can, one sentence at a time.